the 10th edition of Open Source Block Explorers. I can't believe we made double digits. Pretty excited about this. Today we have a pretty good one. We have lots of updates from lots of people in this space. So if you've never seen this before, there is a surprise in store. We have a centralization issue in Ethereum. We have one block explorer that can show you internal transactions and that everyone goes to see the truth of the blockchain. And while Etherscan is awesome and we love it, it's still pretty much a monopoly. And so we have some heroes in the space that are working to bring more options to the table, especially around the idea of seeing internal transactions. And so we're going to talk to them today. So let's get this show on the road. We'll do a quick intro. As you guys all know, you've been here many times. Just keep it real quick. I'm Griff Green. I work for Giveth, and I'm trying to push this working group along on open source block explorers. And I don't have any real intentions for the call other than just to have a good time. How about Mitch?
Sure bet. My name is Mitch. I'm with the ETH Prize Initiative. I like to talk about pain points in the Ethereum ecosystem and hopefully addressing those.
And Kit?
Yeah. Hi, my name is Ankit, and I am co-founder of Analyse Ether. And our objective is to make data analysis of Ethereum as easy as possible and as open as possible. And today I'll like to present some data analysis on how much time it takes to extract data from an Ethereum node. So that's all from my side.
How about TJ?
Yeah, my name is Jay Rush. I am working on a project called QuickBlocks. And I'm really interested to hear about how long it takes to extract data because it's really becoming an issue.
Yeah, 6 million blocks. Andrew.
Hey guys, I'm Andrew. I'm with POA Network. I am project lead on our open source Block Explorer project. For this call, I'd love to provide some updates on what we've been up to the last couple of weeks.
Well, while we're on you, Andrew, why don't you just start with those updates? Sure,
that sounds good. So over the past couple of weeks, we've closed 32 of our open issues. Just going to go over a couple of our bigger enhancements during this time. For Indexer, so on the last call, I talked about how we have two separate indexers. They both work simultaneously. One goes back in history, it's called our Genesis indexer, and we have one real-time indexer. It catches new blocks as they come in and puts them in the database. So we were seeing a problem. So our front end is real time. So we get real time events and everything pops on the screen without ever having to refresh. But our real time indexer was getting transactions, internal transactions, balances asynchronously. So if a user's on the address page and a transaction came in, the balance in the transaction wouldn't happen simultaneously. So over the last couple of days and going into next week, this has been a big area of our focus. Also in the indexer, we did complete some functionality to fill in missing holes. So you could delete a block range, and within a couple minutes, all those blocks are re-indexed. So this will help us when we start tackling block reorganizations and so on and so forth. What else do we have? Oh, we have a big announcement for our tokens. So for our version 1 release, we will be supporting ERC 721 along with our ERC 20. We have some game developers that will be deploying on POA Network. And the first is Doperator, which launches on July 30th. And then on the front end, we have our real-time updates on the address page, which is completed. And then on the block details page, all our real-time events are completed and partial on the home page. So by next call, hopefully we have all the real-time events completed on the entire site.
Wow.
So that basically covered, yeah, that covers our big enhancements for the last couple of weeks.
Nice. What is the status like if people wanted to try to browse right now on what you have? Like, is that doable or not really yet?
Yeah, you could deploy it right now. Just on our GitHub page, there's directions, and you'll have the entire chain indexed, and that's for our POA network. You could switch it to Ethereum, either Geth or Parity. That was actually another enhancement this week. We had some community support. Somebody came in and completed our Geth capabilities along with parity, so you could use either and launch Ethereum, basically any EVM chain.
Very cool. Did you? How do you deal with contributors? Like that guy did that. Like, do you
Sure.
reward him?
We're getting that set up right now through Gitcoin. So some of our bigger issues, if people want to help out, just either email me at andrew@poa.network or go right on our issues tab and make a pull request, and we can communicate there.
Cool. Very cool. Any other questions for POA Network? Moving on. So Ankit, I'm excited to hear this data information. How long does it take?
Yeah, so this is not exactly how long does it take, but I wanted to do analysis on how long does it take to get out internal transaction data from, for example, a parity node. And we know that Ethereum has a block time of 15 seconds. And so is there a condition that we sometimes take more than 15 seconds to get the internal transaction? Because if that limit keeps on hitting consistently, then any block explorer which tries to get internal transaction will consistently lag behind the Ethereum blockchain. So that is how we propose the problem. And I just share my screen, and I think I'll also send you the link, but all the data analysis is public. So anyone can go and run that analysis on his own. He can just copy our GitHub repo. So this is the analysis, and I'll send Griff the link for this analysis. And we use Python, and our objective is to see if the time taken to get the trace or internal transactions exceeds 15 seconds. And so these are some basic procedures to get data. We use Web3Py to get data from Ethereum node. We have a archive parity node which gets all the data. And this is boilerplate code to extract data. And here we have some basic plot. So we have plotted time taken to calculate the trace with respect to block number, and time taken to extract almost 100 address balances with respect to block number. And we see that it keeps on increasing with block number. One more thing that I want to point out is there are these three huge huge time takens over here, which is due to the Shanghai attacks. And we'll eliminate this in the next plot. Next, what we'll do is we want to find a correlation between this time taken to extract trace and maybe the gas used or the number of traces in that particular block. So this is time taken to get the trace for each and every block number. So for block number 1 million, this is the time taken to extract trace, etc. and etc. We calculate the correlation with the time to get trace with various variables that we thought were interesting. And we see that it is very highly correlated to the gas used in that particular block and the number of traces in that particular block. And so we'll just plot the trace, time taken to get the trace with respect to gas used and with respect to the number of traces. And we see that there is a direct correlation between these two plots. And this is just basic data analysis that I do after that, which is basically I build a linear model between this variable and gas used and number of traces to see what are the coefficients. How does it affect? And this is the code to generate the linear model. And we see that for every 1 million extra gas used units, we take almost 1.132 seconds. And over here, we already see that we start exceeding that 15-second block time limit to extract the traces, but that does not happen consistently. So at 8 million gas used, that limit is not reached consistently. But if we extrapolate using this basic linear model, we see that as we reach gas used at 12 million, we will consistently keep on hitting, we will consistently overshoot that 15-second block time limit. and we will consistently lag behind the Ethereum blockchain.
Can I ask a question?
Sure.
Is that independent of the method that you use to extract the data? So is that all the node, the time is spent the node delivering the data? In other words, are there more or less efficient ways to ask for the data?
That's RPC, correct?
Yeah, is it RPC?
This is IPC. I'm using IPC to get the data right
IPC?
now. Not RPC. So IPC is still better than RPC.
Yeah.
But I don't know. There can be some optimizations that happen in the node code to extract the data more efficiently. Or there might be some optimizations available in the web3.py library to extract the data more efficiently. But I think this is the fastest that I have right now.
Okay.
If we don't optimize those two libraries.
This data is so excellent. I'm so excited to see this kind of stuff.
And so Ankit,
this is open source, and you can execute this on your own as well if you want.
Yeah, that was my question. It's like make sure to get your brand out there. So how did you get that data? And can you tell a little bit more about your project for newcomers to the stream as well?
Yeah. So our project is Analyse Ether, and we want to make analysis of Ethereum as easy as and open as possible. So anyone can open our website and run SQL queries on top of Ethereum data. So if you want to analyze any smart contract, if you want to analyze how certain prediction markets are behaving or how certain decentralized exchanges are behaving, you can do very quick data analysis and make it shareable to anyone publicly. So this is just one part of what we are trying to do. And we are trying to extract more and more types of data. And so we do keep on hitting 15-second block time consistently, because we also extract state for our data analysis. But this is something that I found is relevant to also block explorers.
Yeah. Excellent.
Yeah, really incredible data. I hope both the clients get to see this. I'll try to make sure that they see it at least.
Are you inserting at the same time when you're collecting, or is this just collecting and then throwing it away?
Right now, this is just collecting.
Yeah, I mean,
yeah.
Go ahead. No.
And I've asked Emil on his side to corroborate whatever I found, so that we have a much more solid understanding. So two different teams are corroborating this data analysis, so that we have a much more better argument to put forward.
Yeah, I mean, it looks like you found a legitimate, like, another reason that we have to stop max gas at 12 million for sure. But even 8 million is pushing it, because we have some that are, it looks almost like you could, I guess it's not really DOSing the network. What if let's say that your hypothesis or that you were testing ended up saying, yeah, you know what, you can make 8 million gas blocks that are over 15 seconds. What would that result in? Would that be a DOSing of the client effectively?
Like this is to get the data of trace. Maybe the client does, since the client does not have to deliver the data, it does faster than 15 seconds. But if you want to build a block explorer by extracting the data, then you will consistently lag behind.
Okay. Well, any other questions for Ankit?
I'm going to push back a little bit on that.
Yeah.
So one of the things that I'm thinking about, my work like constantly forces me to look at the node more carefully and kind of say, hey node, you have to get better. So to me, it seems that if the node can generate the data at whatever speed it generates the data, then the extraction of the data, if it were designed to be as efficient as it could possibly be, could keep up with that as well. So the node is generating data. And if it's 1,000 transactions a second or whatever number it is, then it should be able to provide that data outside of itself. I think one of the problems is you have to go through an interface to get into the node. And one possible solution would be to put hooks into the node code that would allow people to write extraction code. So that could be as arbitrarily complex as you want it to be. Some people might want to extract very specific things like I do, which is just addresses or something. Other people might want to extract the entire database. But if the node can keep up with itself, then the extraction should be able to as well, I think.
Well, one counter in its current state, if those hooks aren't built in, then I think then we have the issue that Ankit is describing. Is that correct?
Well, yeah, maybe.
And this is just for internal transactions. That's the most expensive call. It's it's important to keep that clear. Yeah, they're extremely slow, slow compared to just transactions or other data. Especially
those DDoS, especially the DDoS. The DDoS are unbelievably slow. No, you're right. I agree. It's basically, I've almost come to the conclusion that there is almost nothing else interesting other than the internal transactions, except for the state and so forth. But the transactions themselves are just internal. They're sort of internal transactions in a way. I mean, they're in parity. They come through as traces, the same as any other trace. Yeah, but I always push towards the node to try to improve the node so that it's better at giving its.
But I do think that Griff was onto something when he said that we could be DOSing the node if we go over that 15-second time limit. I mean, we've seen it when I'm running, just for stress testing, running 3 or 4 indexers on our chain. I have seen when just for internal transactions, the node slowing down incredibly when we are running multiple. So if we're going over that 15-second time limit, that's definitely a possibility and a problem.
And I mean, you can make arbitrarily complex internal transactions, and if you're targeting the network and you're actually trying to do it, you can probably find a method that goes really complicated.
So there is one more parameter, which is number of traces in the model, which basically signifies how complicated your internal transaction is. And so if that becomes also much more complicated, you can maybe start DOSing the network at a lower gas use or a lower gas limit.
Well, this was incredibly fascinating. Thank you so much, Ankit, for doing all this work. I'm really impressed. So, and I'm very excited. I hope you can put the link to this in the notes, and I'll link to the data in the YouTube stuff, because this is really interesting. But next on, we've got to move on. Next on the list is QuickBlocks, a call for contributors. I'm excited to hear what you got, TJ.
Well, my name's Jay Rush. I'm talking about project my name's TJ, talking about my project QuickBlocks. And first of all, I just want to tell people we're probably going to have to change the name, because Quick is apparently used by some big corporation to do something related to accounting. So that's the first thing. So we're thinking about what the next name is. But
I recommend Mitch Blocks.
Okay.
It has a nice ring to it. Please don't actually do that. Sorry.
I won't. I promise. So about 3 weeks ago, we put a different license in our code so that it is open source, and I'm trying my best to understand how to be a good open source place, a good open source project. So we are starting to get people interested. They're downloading and building the code and everything. So we're open for open source contributors. It might be a bumpy ride, but everybody's welcome. The other thing I was working on with Emil, we shared some data and we were trying to confirm each other's data. And I thought that was really great. And I'd love to have this group kind of build a collection of test data that anyone can kind of try to replicate or help identify problems or help identify missing data or extraneous data. And I think there's actually two different kinds of data. There's probably way more, but at least two. The first is the type of data that Emil provided me, which is sort of summarizing across daily, weekly, monthly, summaries. And then there's per account data, which is what I'm really interested in. So I was thinking two really nice test cases would be the Ethereum Foundation's addresses and provide a list of every transaction up to block 6 million, including all possible places in all these internal transactions that we're talking about. So I'm creating a Gitcoin bounty to invite people to, I have this list already, so I'm inviting people to find missing transactions. And what I did is I took all of the transactions that I think exist in the Ethereum Foundation tip jar, and I deleted 5 transactions. So the bounty is find those 5 transactions and I'll pay you. And then I was thinking that this would be great for the Ethereum Foundation because then they could do accounting if they had a list of transactions that was verified by 15 different open source blockchain groups. And then I thought, Griff Green is the greatest person in the world. I'm going to do this for Griff Green as well. So I'm going to do Giveth as well. So.
Oh, nice. Yeah, we actually do have an open source block explorer DC. And so we could definitely work on that together.
Yeah, I'm very interested in transactions per account. So I want to include that in the test cases. So that's where I can, and I can help think of ideas to test as well, different kinds of data. I'm starting to create a list of what I call weird transactions, where they have these multiple, one contract creates 10 contracts, which creates 30 contracts, which all interact with each other in a single transaction or something like that. We can also write test cases on purpose that do these kinds of things on purpose to try to make difficult test cases. So I'm kind of interested in that as well. So that's all I got.
Cool. I guess just make sure to, for everything with this, there'll be a nice probably a link to your repos and all those things in the YouTube comments, or excuse me, the YouTube details.
Yeah, as long as you put them on that Word doc that we share around, it'll get out there.
Hey guys.
Hey, welcome, Emil.
I managed to get in eventually.
Yeah, and you're up. You actually have this agenda item.
So I'll do I missed most of what you said, trying to figure out Google Hangouts, but forgive me for that. So my name is Emil. I'm with Web3Scan. We are building, one of the things we're building is the Block Explorer, but it is part of a larger set of tools in us becoming a data integrator, data aggregator, focusing on multiple blockchains. So I missed most of what you guys were saying, but in the end, perhaps because I did get some of it, it's good that I came in last, because I want to show you something we built in our Block Explorer, and I think it might wrap up bits and pieces of the discussions that were going on previously. So give me 3-4 minutes and I'll click around and I'll show you. And then perhaps it's a good time to get a discussion going about that. So, yeah. So please shout if you can see my screen, then I know enough.
It's looking good.
Okay, so this is, the data is a bit outdated, but that's besides the point at this point. We have multiple blockchains in our Explorer. I'll go to the Ethereum mainnet because most of you are familiar with that one. I want to show in this short demo the block overview and the block detail page. So in the block overview, well, most of it will look familiar, but I'll go over the columns that are visible. It has.
Can we bump the font a little bit? I'm sorry, I'm kind of old.
Yeah, sure. Ugh, crap. This should do it.
Thank you.
That better? All right. So there's the block column. It has the block number. It has the block hash, and it has the block time, which is the timestamp difference with the previous block. It has a datetime column, which has a time ago JavaScript front-end counter, which actually counts how long it was ago that this block was included in the blockchain. It has the actual date time in UTC time. It has the what's it called? The icon. There's a name for it. It's the one some of the other block explorers are using as well. I believe Alex van der Zande created that once, and it has the address, of course. So gas, this actually describes what the block size is and what the gas used is in the block, and it has a block utilization percentage, which actually shows you that these blocks are pretty full nowadays. The gas price, it has the average gas price for this block and the top gas price in gigawatt and the minimum gas price. Well, these numbers actually get more interesting if you aggregate them over a larger number of blocks by day, by month, by week, that sort of thing. And this is, for example, what the gas station works with aggregate data to do some predictions. What is a safe gas price for your transactions or not? So it has the number of transactions. It has the number of internal transactions. The internal transactions as used by Etherscan, and it shows you how many errors happened in the number of transactions and the number of internal transactions. It shows you the number of event logs. It shows you the number of transfers. I'll get into that in the detail page. But what is interesting is that it shows you how much Ether was minted, created out of thin air. So especially if you go to uncle blocks, blocks that have uncles included, you see that quite a lot of Ether is minted. And as soon as you go to two uncles, which sometimes happen, actually 7 or 8 Ether is created out of thin air. So that's one of these things you don't notice pretty well if you look at the other block explorers. So this is the total fees that were paid for this block. How many agents were seen? So the term we use for accounts is agents. There's a whole story behind that. I won't get into that today, but there were 757 agents accounts seen in this block alone. So this gets into Thomas J's story, I guess, and 269 distinct agents. 3 agents that were never seen before since the Genesis block, and 0 contracts were created in this block. Throughput, how many transactions per second? Again,
I'm just going to jump in really quick. This is freaking amazing. Thank you.
Yeah. Give me 1 more minute.
Okay. I just wanted to say how amazing this is.
Thank you very much. So the throughput, 14.29 transactions per second. It's basically the number of transactions divided by the block time. So this number gets more interesting if you aggregate more. So look at the daily stats or the weekly stats and so on. A more or a better way of looking at throughput, in my opinion, is the number of the amount of gas that is processed per second. So that's basically the gas used, 8 million in this case, divided by the number of seconds. And this is a very useful metric if you aggregate more. It's very comparable between all these different blockchains. So another term we introduce is the, well, congruent transactions per second. Now, everyone knows that a regular transaction costs about 21,000 gas. So if you divide the number of gas per second by 21,000, you get equivalent or congruent transactions per second. So if Ethereum were only pushing through regular transactions, then its capacity would be this number. So that needs to sink in, perhaps. So one more thing, the detail page. I'll need 1 minute for that. It shows the regular details. It shows, very importantly, on the second tab, a very large number of fields with all the properties we got in our block explorer per block. So, for example, this is the difficulty, this is the number of events or event blocks, the gas limit, the average gas price, and so on, the number of traces, the number of traces by type, the number of transactions, well, and so on and so on. And in this third column, it shows you the cumulative number for the entire chain up to this block. So one example, the size, which is a simple property of a block, is 21 kilobytes, and it's 48 gigabytes. So this is actually the block size of the chain size. Well, and there are all these other cumulative values we have for all these other properties. So I would check it out. The very nice thing about this is there is a copy button. If you press it and you go to Excel and you paste, you have it all nicely in your Excel. There is a print button. I won't go into that. And it shows, I'm moving on to the next tabs, the number of transactions. So this shows all transactions for this individual block with the sender, the recipient, the value, and the status. And you can get it into Excel or print it. You can actually search for it. So I'll type in coin. This comes from the contract name for which we have verified contracts. So it searches pretty fast within a single block. All the events, so you can easily search for a topic within a block. The traces, you can search these. The transfers, I'll get to that in the next call perhaps, but just for Thomas J, I'll finish with the agent audit. So this is a list of all the different addresses that were found within this single block. So there's all the way down, it's about 800, I believe. So there are 757 different entries. You can all get them to Excel or print them or search through them, sort them, and this is actually the index of the transaction, the trace, the event, or the uncle in which the address was found. And it is deep linked, so you can go directly to that block. So, and we not only have this for the mainnet, we also have this for the Tobalaba network, for Kovan, and for the POA network. So I guess this is it. Am I back?
Yeah, that was really cool, man. That's really interesting data. So nice displayed in a different way. You know, you only see Etherscan pretty much. So I don't know. I'm sure lots of people have questions. Agents, is that, I assume you picked agent because some of them are contracts, not accounts? Or? Yes,
it's a more neutral term. I'll try to write something about that sometime soon, but I've never been really happy with smart contracts, and well, there's lots of discussion about it. So we opted for internal agents and external agents. It's a more neutral term, perhaps, especially since our blockchain explorer will need to go beyond Ethereum or EVM smart contract platforms at some point. Yeah, we might change that. I don't know. We'll see. You need to pick something.
Anyone else have?
I'll spend the next call. I can highlight some of the other stuff we've built into the Explorer. So it's always good. You don't have to respond to this now. Perhaps we can go into this another time as well.
Yeah. Well, I'm curious. TJ seemed to really love it. What was your favorite part, TJ?
Well, I just think it's excellent. It's absolutely excellent. So it's exposing data that my work, and that'll help my work because I've never had a real easy way to verify what I'm doing, for one thing. I don't, I'm producing lists of transactions per block, but I don't have a definitive list of transaction block. And this is one thing that we should be really careful about because that may or may not be a definitive list of blocks, but the concern is that it becomes the definitive list of blocks, of addresses per block. So we want to be very aware that these things become the de facto standards, and then we have to have a difficult time explaining or expanding on them or detracting from them. So just keep aware of that it will become a standard, because that piece of information right there, to me, is profoundly interesting to people, because what they can do is pull that data down and filter it for their own account, and then they can write software that pulls the data directly from the node. And while it's very slow to extract the data from the node, if you already have a list of transactions per account, extracting all of your transactions is very fast, actually, if you know which transactions to extract. So
it is very hard to get some sort of hosting or online sharing of that entire database. So we need to look for methods, but this is a start to provide this per block and vice versa per account that was included. Perhaps what I can do in the next call is give this same demo, but then from the accounts perspective, because you can do all these references, not only from the block, from the transaction, from the trace, and so on, but also from the accounts point of view.
Right.
And that's much closer to what you're working on, of course.
And then the issue of the delivery is very, very important. And I agree with you. It's difficult to provide to the world this data from a server or something like that because of all the costs associated with providing it from a server. So I wish I could just magically invent some way to deliver data to people. I think it might be IPFS. So I'm like trying to figure out how we can use some decentralized data store like that to get people data that they want. I have no idea how that might work, but
once file is implemented, then you can basically put a bounty on it, right?
Yeah. So but I find that really interesting. My list of transactions have additional. The one thing that happens is there's about 8 places in the data where addresses appear explicitly as an address, but then they also appear in the input data or in the traces input data or in the data of the events that are not indexed. And there's addresses in there as well. So I'm picking those addresses out. That's completely impossible, but I do the best I can. So
well, just wait, guys.
I bet you excluded these ones in your bounty.
No, I didn't.
Well, what's going to be exciting is when we have arbitrary message passing and bridges. I mean, at least with Giveth, we have a bridge between Rinkeby and mainnet. And so, we're going to, when we upgrade that bridge to have arbitrary message passing, we're going to have, straight up data that is going to another chain that doesn't get actually executed in the main chain. but it's going to trip all your sensors and make you think that there was a transaction on the main chain, when really that's just data being sent to a side chain. So,
well, I think yeah, that there's almost a difference between a transaction and a usage of an address as a piece of data in a smart contract. And I think I'm interested in both.
Yeah. Mitch, you had something you were going to say?
Yeah, my question was just for Emil. So if people would want to spin this up, is this currently live at the moment? And also, how much is open sourced at the moment, so people could kind of like chew on it themselves?
Yes. Well, you know, this is my summer break, so I haven't actually been able to do much since our last call. We have a large database, and we have a harvester on top of to harvest all that data. And on top of that database, we have a API layer and a front-end explorer layer, the GUI you just saw. So I'm not yet really happy about it. There was some time pressure to get that delivered 2 weeks ago for the last call. So that will go through some review, and these latter two will be open sourced, the API and the GUI, but it's not there yet because I simply don't have the time yet.
Well, you're hard on yourself, but I liked there was some extra quality that was nice, like when the Identicon goes from circle to square. You know, these little touches of quality really add some value to it. So I appreciate it. It's much better
That's
than
the default behavior, so I can't take the credit for that. So if anyone wants to check out the Explorer, the address is in the notes. Griff, you had that changed, I believe. And the address is explorer.web3scan.net. So go check it out.
Nice. Well, are there any other fireside chat type of topics you guys want to cover really quick, or should we just end this bad boy?
Yeah, I have one more question for Emil. It was really interesting to see all the metrics that you had shown during the GUI. But you said that the gas used per second is some metric that you find very, very interesting. Can you explain more why you find that interesting, so that we might have more exposure?
Well, it's interesting because it actually says something. The number of transactions per second doesn't really mean anything, because you never know how many of these transactions were sent to a contract and invoked all this other stuff you're unaware. So a single transaction can consume all the gas in a block, but it could also consume almost nothing because it's a regular value transfer transaction. So if you look at how much gas was processed per second, then that's, well, I think a better way of looking at the throughput dimension of a blockchain, because that's what the blockchain crunches through in all these state changes, whether it's the Ether state change or a contract state change. Does that answer your question?
Yeah, it does. It does.
Okay, great.
Thanks a lot. Great job.
Nice.
Thanks.
Well, cool. Well, then let's end on a high note, huh? Thank you guys so much for coming, and I'll see you guys in 2 weeks. See ya.